Hey guys, I want to show you this homemade HHO Dry Cell Generator. So the generator is mostly built from scrap material. The only thing that I had to buy were the bolts and washers. So the end caps of this generator here are just 1/4-inch steel plate that I had laying around. The stainless steel is out of a refrigerator I cut up. The rubber gaskets are actually inner tube rubber. So I just built this HHO generator for myself. It's just for a project, something to do. So in this video, I'm not going to get into the why you want to build one of these or what they're for. You can look that up. There's so many channels on YouTube. There's got to be hundreds of channels and thousands of videos on this alone. So you can just check those videos out to learn what this is about. This video here, I just want to focus on the construction. So I'm not an expert in any way. So check out their channels and their videos. So this 11 plate design, we have 8 neutral plates. So we have 1 power plate, 4 neutral plates, another power plate, another 4 neutral plates, and then another power plate. So we have 3 plates. These 2 here are negative and the center one's positive. Now you can wire it the opposite way if you want. You can have negative in the center and then 2 positive. So I'm going to hook up the unit and see how it works. Generator hooked up temporarily to this water container here, which is feeding water into the bottom of the generator, and then I have the output gas line going up to that little water bottle there. So if I turn this on, bubbles should come out of that little water bottle there. Okay, so I turn the generator on. So there it goes. I start putting the generator together, I just want to say a word of caution. Do not try this at home. This video is just for entertainment purposes only. So I'm using some scrap stainless steel. So the stainless steel was out of a little milk fridge, and I've just removed the stainless steel insert that was actually in there. You can see here it had some tubes on the back of it for the refrigerator part. And so what I've done is I've just cut this out of it. Is a commercial stainless steel. So I think it's probably 316 or whatever, the good stuff. So what I do is I check the steel with a magnet, and stainless steel, the magnet should not stick to it whatsoever. So out of this piece of metal here, I can get 8 5-inch plates. And all I have to do is just measure these out now and cut them out. So now I need to drill the holes in the plates. So what I've done is I've just sandwiched them together in these clamps here, and I've drawn out the holes, the spacing, and basically they're spaced out evenly on the plates where the gaskets are going to be. Now what I'm going to do is I'm going to start one hole, and then I'm going to drop a bolt in, and then I'm going to go around and continue. So that'll hold them together in place. So let's get started. So I'm going to put a little bit of oil. What I'm using is just transmission fluid and water mixed together as my drilling oil. And it seems to work okay. So this is just a backyard build, and I don't have the equipment. I have the neutral plates drilled. Now I need to drill the power plate. I have 3 power plates in this dry cell. And what I'm going to do is I'm just going to lay the neutral plate on top of the power plate. Now this plate here is larger, so then I can attach my terminals to it. So and then I'll know which ones are the power plates as well. So now this plate is larger than the neutral plate, so you can just lay it on top. And whatever way you want to do this, you could clamp it down and then drill it, or you could just mark it with a marker. So I think I'm just going to mark it, the holes, and then I can just drill it out. So drill the last power plate. Now you can see that it drills a lot easier when you're just drilling one plate at a time. So either way how you do this, you may want to just do it this way, one plate at a time, because you're going to go through a lot of drill bits. You're going to have to sharpen. Okay, so if you drill your plates one at a time and you have this happen where the metal is actually pushed down and all jagged, then you're going to have to smooth that out before you go to put this thing together. So what you can do is you can hammer it down and then drill it out, but it won't be quite as smooth. So you should take a small grinding disc and just go over the area and clean it up. That's what I'm going to do. So I'll just use the Dremel and just clean up these burrs here. Once you've taken the worst off, then you can then flatten it down with a hammer. So just put it onto a piece of steel, an anvil, and just flatten it down. So now it's smooth, and you can run your hand over it, and it's not grabbing any material, the gloves. So what you can do now is you can then run it back through the drill again, and that'll just open up the hole and make sure that you have the 1/4 inch hole that you need, or whatever size bolt you're using to clamp these things together. So once you've drilled all the holes out again and they're at the proper size, then you could run the Dremel over top with a sanding wheel on it and then take off any burrs. Like there's some there you can see. So you want to have this as smooth as possible. So I'm going to drill the end caps now. I've already drilled some holes in it. So for my gasket material that will go around the outer edge here of the plate, to isolate these plates from each other and to seal them together to make them watertight, I'm going to use this inner tube rubber. And so I have an inner tube here. This is out of an old tractor tire. So I'm going to make the gaskets now. I have the rubber here, and I'm just going to lay the plate onto the rubber. So what I'm going to do is just take the knife and I'm going to use it to actually mark out the gasket. And I'm just going to push down. And this will give me an outline, basically, like that. So once you've got an outline, then you can just cut it out. So I'm just going to cut them out. Now, if you don't want to do them by hand, you could make a die, and then you could put the die underneath of a hydraulic jack, and you could just press out the gaskets, so you'd be able to make as many gaskets as you want, and a lot faster. What I've done now is I cut out a piece of sheet metal that is 3/4 of an inch smaller than this gasket here. So I could just lay that on in the middle here, and basically you can just measure around if you want and sort of line it up till it's in the center, and then all you have to do is just take your knife and you can just hold this down and you can just go around with your knife, and then that'll give you the exact distance all the way around. You could also use a sharp enough knife to cut right through the rubber, and you could just cut it one shot. So I got my impression there, my outline. What you want to do is poke a hole, basically, so that you can start your cut. And then once you get your hole started, then you can just go around. It's really easy. And just cut it out. Okay. So now I need to put the holes in the gaskets. So I have my gaskets here, and what I'm going to do is I'm going to take one of the neutral plates, and I'm just going to lay the neutral plate on top of the gasket. Drop down a gasket like that. Place the plate on top and square it up as best as possible. Doesn't have to be perfect because the gasket material is a little larger than necessary. And then I'll just take the marker and mark the holes. Now, a colored marker would be a lot better than this, so it would show up on the black, but it does show up, so it'll be alright. Just to go around, try not to move the plate in any way, or the holes will be marked wrong. And you can see now the markings on there. So now when making the holes, drill bits don't really work well for drilling out rubber or gasket material like this. So I'm just going to use a punch. I've made a little homemade punch here, and I could also use this eyelet gun. The eyelet doesn't work very well, this punch. So, but this one here works fine. It's just a bolt where I've drilled the center, and then I've just sharpened the edge around, and just put it over the mark, like that, and then hit it with a hammer. May have to turn it and then hit it again. But it seems to work. And now we have a hole, and it should line up with the plate, and away you go. So I just got to continue punching out these, and I have a whole pile more to do, so that's going to be a slow process. So now we need to put some holes in the plates to allow the liquid to get in and the gas to get out. So what I'm going to do is I'm going to put a hole over here in this corner here on this number 1 plate here, a power plate. So now on the neutral plate here, I'm going to put the next hole right here so that they don't line up. And I was reading about this, and it's better to actually stagger the holes, because then you don't have the holes all in line, because then there could be voltage seepage. So the next one now on plate 2 will then be over here. So you can see what I'm doing. It starts here, and here, and here, and then the next one will be over there. So none of these holes are going to line up. And now on the vent holes for the gas, I'm going to put a hole up at the top, but I'm not going to stagger them too much, because you want the gas to get out as quickly as possible. So what I'll do is I'll put one hole over here, not quite as far over to the corner. So now on the next plate in line, the neutral plate, I'm going to put the hole over here. So they're not going to be too much out of line with each other, because you don't want too much restriction with the output gas. On the end cap, I just laid a gasket, and I'm going to put a hole basically right in the center there. On the next end cap, I'm going to have a hole at the top. So this will be the inlet end cap, and then the next one will be the gas output. So the generator will be sitting up like that. Liquid will be coming in through here. It's going to fill up through all the plates, and then the gas on the last end plate will be coming out at the top. So I'll show you the alignment of the plates here. I have the power plate negative here, 4 neutral plates, a positive power plate, 4 neutral plates, and then a negative power plate. So these neutral plates here don't actually have any connection whatsoever. They're just in between with a gasket. The only plates that we apply voltage to are to the power plate. So why we want to use these neutral plates here is because of our source voltage is most likely going to be around 12 volts if you're going to be using this in a car or whatever. So what you need to do is you need to reduce the overall voltage between the plates. We don't want to have 12 volts across these two plates, because if we do, it's going to wear out this metal plate very, very quickly. There's going to be too high of a voltage. And that's why we use these neutral plates. And because with electrolysis, you don't want any more than 2 volts between each plate. Because what happens is if you put too high of a voltage, then the metal will start to break down and it'll just erode the plates. There'll be too much current and the plates will just wear out very, very quickly. We don't want that. We want to try to conserve the metal, the stainless steel, as long as possible. So now to put this thing together, we have the two end caps. We're going to place a gasket in between here. So a gasket's going to go in here. And then we'll put the first power plate, which will be negative, and then we're going to put another gasket in here, and then a neutral plate, and then a gasket, then a neutral plate, gasket, neutral plate, gasket, neutral plate, and then a power plate, the positive plate. And then we're going to put another gasket, and so on and so forth until we get to the end here. So I'm going to start putting the generator together now. I have an end cap, and I have my bolts. Now these bolts here, I actually ground them down a little bit so that the diameter's a little smaller so that they don't short out against the plates. So you don't want these bolts contacting any of the holes in the plates, because then it'll short out between the plates. So either you can coat these bolts with something like polyurethane or paint or something, or you could wrap some tape around them, or you could put a little spacer. So the kits you buy, they actually come with a collar that goes over top of the bolts. Okay, so what I'm going to do is I'm just going to flip this now with all the bolts in there. So I'm going to take a gasket and I'm going to lay it over top of the end cap and the bolts. I have everything marked. I have arrows on the end cap and on the gaskets and also on the plates, you can see. So everything's going to line up, and this is number 1 power plate. This one can be a negative plate or a positive, doesn't really matter. I'm going to use this one as a negative plate. So what I'm going to do is I'm going to drop the plate on now. We've got the gasket on. Okay, so now once this is tightened up, hopefully these bolts here won't contact the plates. Okay, so we put another gasket on over top of the power plate, and then I'm going to lay on the first neutral plate. So it's marked number 1, so I'm going to drop that neutral plate on top. So I'm going to drop on another gasket now. So now I'll put on the second neutral plate. And we'll lay another gasket on. So the neutral plates don't have any connection, electrical connection between them. And so we're only going to contact the power plates. Third neutral plate, you can see the holes, the inlet hole and the gas out hole, and you can see that then on this plate here, the inlet's over here and the gas is over here. So they're not lined up, and I think it's better to do that. I heard drop another gasket on here. Number 4, neutral plate. Another gasket. So now we're going to put the center power plate in. So this is I'm using this one as a positive plate, and the outer 2 will be the negative. Now you can wire it the opposite if you want. This can be negative and the 2 outer is positive. Drop this one in place. Okay. So now if you look at it here, you can see there's a gasket, the first power plate, 4 neutral plates in between, and then the next power plate. So it's pretty simple how this goes together. I'll drop another gasket on. This one's just a homemade backyard build here, so it's not really the greatest. And the plates aren't perfectly smooth or anything like that. So now we're going to put another neutral plate on. This is number 5. And we'll put the next neutral plate on. So now we have all the plates on, so you can just take the end cap now and drop the end cap on. Like that. And I'm going to put some washers on. I'm going to put the washers on. I'm going to put a few extra washers because the bolts are too long. So we'll put a couple on here. Just going to tighten it down by hand right now. I had to put some extra washers on because these bolts were too long. No big deal. Now, you can put longer bolts on here, and then you can add more plates. That's a nice thing about these dry cells. So what I'm going to do is I'm going to torque it up. And so what you want to do is you don't really want to go around in a circle. You want to crisscross. So I have a sequence on here, and I'm going to torque it up. And tighten this up. That's tight enough. They've all been tightened, and now you can see that it's starting to look like a dry cell HHO generator. So now to connect this thing up, you need to hook to these 3 plates here. And you can see I drilled some holes in each plate. So I got a hole here, and a hole here, and a hole here. So what I'm going to do is I'm going to attach 3 wires to this. So the only costs involved in this generator here were the bolts and the washers and the nuts. Now they were about $4, so very little was put into this. So I recommend to check out other people's channels. They have way better generators than I have here. This is just a very basic, roughly built generator. So you know, if you check out their videos, they're building some really nice stuff. So that was my homemade HHO generator dry cell built from scrap materials, and thanks for watching.